I'm just gonna be for the cylinder. Hey, have a good day.
Hi. Okay. Come do it on the board. Just kidding.
Okay. The tough one.
It doesn't help that there's an unconstrained value in there.
Okay. So, I'll call this body 1, body 2.
Is there any chance you could expand that image just a little bit?
And those are already labeled. Okay, so it makes this problem easier if you recognize that this pin here, I mean, I guess it's kind of a hint that they call this piston just a letter, like it's just a joint. But this pin that connects to this piston on member 2 here, notice that that can only slide up or down. And so then you can use that instead of treating D like its own body. But
So you're saying it would just be like the vertical component of the force at D?
so you know that thing can't, that pin connected to the piston can't have any side-to-side acceleration. Well, there's no acceleration here. So what am I trying to say? So let's see.
Like a slot.
Let's see. Yeah, right. You can think of that as a slot. Yeah, it acts just like that. Okay, so free body diagram of body 1. We have a force RA. None of these have mass, I assume. And then up here, there's a force on 1 by 2. And then here, there's a force P. And that is everything. It looks like there's some sort of painful geometry on here. I'll put the about point here. So that first force RA has a 0 row vector. The forces RAX, RAY. Moment is 0. Then F12, that is at, you could do this in meters or you could keep those lengths in millimeters. It'll work fine either way. I'm used to just putting everything in SI units, so I'm going to call that 0.2. So we got 0.2 times cosine sine of 60. So that's 0.10. And then for y, that is 0.1732. The force vector is F12x, F12y. So then you got 0.1 F12y minus 0.1732 F12x. And then that force P is the last one. Okay, so this, basically what I'm going to do is I'm going to calculate the components of the vector going from this pin B to this pin C, and then I'm just going to add it to this last vector we had. Anybody have any questions about how I'm coming up with that row vector? Yeah.
Not quite that last bit. Since this is a rigid body, could you consider body 1 and body 2 the same structure? Or the same?
Yes, you totally can do that, but then you wouldn't be able to calculate that contact force between them from that. But yeah, you could do that to calculate that force at D. Yep. Okay, so this is 0.4 times cosine and sine of 15 degrees. And then I'm going to add that to 0.1, 0.1732. And so the row vector for where this force P is 0.486, 0.277. And the force is 0, negative P. So the moment is negative 0.486 P. And that is everything there. So Newton's second law says RAX plus F12x is equal to 0. RAY plus F12y is equal to negative P. It looks like we're assuming, yeah, so we're going to get our answers in terms of this force P. Okay. And then the moment, negative 0.1732 F12x plus 0.1 F12y is equal to 0.486 P. So there's our first three equations.
Would number 2 be positive P?
Yeah, thank you. And then we'll go to body 2. So this one, and we're trying to find the force applied to the piston at D. So we're trying to find a vertical force here. Okay, that's what we're trying to find. I'm going to call that just R, and that's what we're looking for. There is a force that's keeping this from accelerating side to side. And this is, I guess, this is really thinking of it as like a pin and slot joint, you know. But that's what's going to keep this from moving side to side. So I'll call that, I'll just call that FD maybe. And then we have a force up here, the force on 2 by 1, so negative F12. And this makes an angle of 20 degrees with the vertical. I guess I'll put my about point down here. So this force FD has no moment arm. The force is FD0, no moment. Then R has no moment arm. The force is 0R, no moment. And then negative F12, that is, what's the length of this thing? It does not tell us. Well, we know that, let's see, what do we need here? So we know that the height, I guess, we're supposed to assume that that height is the same as the height of A. So this length times the cosine of 20 degrees has to be equal to 0.1732. So 0.1732 divided by the cosine of 20 degrees. And so I get that that length is 0.184. And so I get that this row vector is negative 0.063, positive 0.173. Well, that didn't come out right, did it? Yeah, I guess that's right. 173. And then the force is negative F12x, negative F12y. So cross product is 0.063 F12y plus 0.173 F12x. Equation 4 says FD minus negative F12x is equal to 0. Equation 5 says negative F12y is equal to negative R. And equation 6 says 0.173 F12x plus 0.063 F12y is equal to 0. Any questions about the setup of the equations? Let's get an answer for this while we've come this far. Okay, so I got RA is 1.09 negative 1.98. and these are multiplied by p. F12 negative 1.09 2.98 p. And then FD, this is the one we're trying to calculate. I got negative, well that is not right. Negative 1.09 p. And then, what did I call that other one? Oh, that is fine. And then my R is the one that I'm trying to calculate, and that is 2.98 p. Okay, so it would have been a problem if that R was negative, because all that's doing is pushing. But we got a positive for that, so that's fine. Any questions about that one? Any other ones of these problems you'd like to see? Okay. Last time we were working on an example problem. I want to just finish this one, do one more, and then we'll move on to the next topic. So back to the example from what day would this have been?
Friday?
Yeah, a week and 3 days ago.
11th, yeah.
Okay, so we had this example that it was like a figure 4 shape. With a pin and slot joint over here. And a 500 Newton force there. We numbered these 1, 2, 3. And then for joints, I called this A, B, C, and D. And this slot made an angle of 20 degrees with the horizontal. The masses of 1 and 2 were 20 kilograms each. And the mass of body 3 is 15 kilograms. And the one place really that was tricky about this was at the joint D. We had to think, at that pin and slot joint, we had to think about which one of these two members the pin was part of. So which one did we choose and why? Yeah, we chose that the pin was part of member 2 because that joint connects members 2 and 3, and 2 is the lowest numbered of those. And we went through already all the free body diagrams and stuff. Let's just get the answer to this.
I think we did free body. Oh, wait.
Yeah, we did.
Oh,
We
yeah.
got all the equations.
So now we have a set of 9 equations for 9 variables. One, two, three, four, five, six, 7, 8, 9. Okay. So these are equations 1, 2, 3, 4, 5, 6, 7, 8, 9. And the variables are RA, X and Y, F12, X and Y, F13, X and Y, F23, X and Y, and then RD from the pin and slot joint, and then constants. For the first equation, F12x, we have 1. RAX, we have 1. F13x, we have 1. And that's it. Equation 2, F12y, we have 1. RAY, we have 1. F13y, we have 1. For the Newton's laws equations, you see that pattern all the time where things are just shifted over 1, you know, because you're going from the x to the y equation. Equation 3, RAX's, we have 0.5. F13x's, we have negative 0.5. Oh, and I missed the constant for equation 2. So for equation 2, there's a constant of 196.2. Now for equation 4, F23x, we have 1. RD, we have negative 0.342. And F12x, we have negative 1. Then equation 5, F23y, we have 1. F12y, we have negative 1. And the constant is 696.2. And RD, we have positive 0.94. And then for equation 6, F12y, we have 0.5. And the constant is negative 598.1. And then the last three, equation 7, F23x, we have negative 1. F13x, we have negative 1. Then equation 8, F23y, we have negative 1. F13y, we have negative 1. Constant is 145.25. And equation 9, F13y, 0.5. F13x, 0.5. And the constant is negative 36.7875. All right, so for RA, I got negative 114.27, 1351.71. For F12, I got 228.53, negative 1196.2. For F13, I got negative 114.27, 40.69. For F23, I got positive 114.27 and negative 185.94. And for RD, I got negative 334.11. Not this one, this one. Okay, it makes perfectly good sense that that RD is negative the way I drew it, because I had it pushing like to the upper left, and you can see that with that 500 Newton force, it's going to have to go the opposite direction. So I don't have any intuition about the numbers there, but that RD is in the right direction. Anybody have any questions about that? Okay, so I guess on Wednesday we'll do one more problem where you have to be like really careful about which member you include the pin with, you know, because we'll have a lot of members at various joints. And then when we're done with that, we'll spend a day talking about the truss simplification, and then we'll go on to internal loads after that. Okay, let's do